Hi, everybody. Welcome to this month's Let's Learn.net. Today, we're going to be talking about all things Azure with our awesome experts, Matt and Alex. And thanks for tuning in. I see we have folks from all over. I'm seeing Brazil, Nairobi, and much, much more. I'm going to be guest hosting for Jamie today. I'm super excited to learn alongside you all. And we have our guests with us, Matt and Alex. Do you guys want to introduce yourselves?
Absolutely. Thank you, Katie. Could not be more excited. And thank you for having us on. So, my name is Matt Soucoup. I am a cloud advocate focusing on .NET here at Microsoft, and obviously super excited to be talking about Azure. I'll talk about Azure all day long. Katie, you know me. You hang up on me on Teams calls all the time because I start
Never,
going about Azure.
never.
So, Alex.
Yeah, it's great to be here. Thanks, Matt. Thanks, Katie. Yeah, I'm a .NET on Azure content developer. So I help out with training the docs, all that stuff. And yeah, it's great to be here. We're going to be talking about some of my favorite topics, and I think it'll be good.
Awesome. Before I let you guys dive in more, I just want to remind everybody, please leave all your questions, comments in the chat. We're going to be going through those and answering them as Matt and Alex go along, but I'll let them take it away and get into what we're here to talk about.
Great. Thanks, Katie. All right. Alex, we're talking about Azure today. What do you think about that? Alex, so I know you write a lot of our documentation on .NET plus Azure, and it's a lot of fun. And I do a lot of the annoying stuff. Like, so if people are learning .NET and Azure, that's your stuff. If they're getting annoyed with .NET and Azure, that's my stuff, right? So I'm out there talking all the time. You're the one that's actually teaching people. So, yeah.
Well, yeah, usually I'm a more behind the scenes kind of content guy, but yeah, it's great to be here. I don't think you're annoying. I'm glad to be here with you. So it'll be good.
Well, thanks. I appreciate that. So let's actually jump over to the slides and we'll get started right away. We're going to be going through everything .NET and Azure related today. And so, yeah, first slide, we covered that already. And so let's go right into the second slide. And we're going to cover a bunch of different topics today, Alex. We're actually going to break this up into two different sections. We're going to be talking first about what cloud computing is. And this actually section is not related to .NET at all. Rather, it's just the basics of what cloud computing is overall. Things like shared responsibility model, different types of cloud-based stuff you can do, like on-prem and cloud at the same time, hybrid or just private clouds or all the way up in the cloud, all the stuff. And then we're going to get into mixing the greatest platform in the world with the cloud, and that's .NET. What do you think, Alex? Sound like a plan?
Sounds like a great plan.
All righty. So let's kick it off. And so we'll start talking about the very first thing, and that's the introduction to cloud computing. And so just our basic concepts as we go along here. And so the very first thing is the shared responsibility model, which is the very basics of things that go along. And so, Alex, you want to explain this a little bit to us?
Yeah, so a lot of people have probably heard of the shared responsibility model, but they might not have gone in depth with it or might not have looked at all the different pieces of it. So if you think of like a traditional on-prem data center or whatever you're using to host your apps and IT, with an on-prem situation, you're kind of in control and responsible for everything. So your hardware, your networking, all of the applications sitting on top of that. And so in the center here, we kind of break down all those different responsibilities, like the information and data down to the networking and physical network. And as you start to think about the cloud or move things to the cloud, there's pieces of those that will stay your responsibility, pieces that will kind of transition, and you're sharing those responsibilities with the cloud provider. And then there's some things that will stay or that will become fully the cloud provider's responsibility. So things like the physical machines, the physical network, the data center, obviously that's going to be the full responsibility of the cloud provider in situations where you're using that. But some things will always stay your responsibility. So at the top there, your information and your data, your actual devices, laptops and PCs that people are connecting with, managing the different accounts and identities for your organization. That's always going to be your responsibility to, at least to a certain extent. So just kind of thinking about those different pieces and how you're going to distribute those as you start moving things to the cloud.
Yeah, that's actually a good point. I'm glad that this diagram separated it out where we have accounts and identities separated from identity and directory infrastructure, because the accounts and identities, that's like creating an account. That's like saying, Alex Wolf, you have an account and this is going to be your password, right? You are responsible for maintaining that. Whereas the identity infrastructure, that's like Azure Active Directory. Like, so in this, we're saying, you know, but Microsoft in Azure is going to take care of like sending two-factor authentication with that. But overall, the password is up to you, Alex, to maintain, so you don't leak all the information all over the place. So
yeah, it's a lot of responsibility. But the part that's always most interesting to me is kind of that middle slice where, you know, you're kind of sharing things. So, you know, you might have an application hosted in the cloud and, you know, the provider's taking care of a lot of the infrastructure for that, but you still might have to perform certain configurations or tweaks to get your application running and accessible the ways you want it. So that middle part is where a lot of people often have to do kind of the most learning or training or figuring out exactly what they want for their company and their situation.
exactly. And that's where we'll actually spend the most time, because as .NET developers, that's where we live. We really live in the platform as a service, the PaaS as a service section, where we actually have to write the applications and then we deploy it onto something. And so that's where things become interesting. And see, as you can see, the applications there, it's kind of, it's the double side of things. So, all righty. So let's see. Cool. And you know what, Alex? I think I forgot something. I think I forgot to include the video that we put together for this. So let's see. Katie, are you behind the scenes? Do you want to pop that video up right away?
What is cloud computing? Just like when you shop for your own computer, cloud computing lets you choose the power and features you need to run your software. The difference is, with cloud computing, the PC is in a cloud provider's data center instead of physically with you. This lets you pay for only the services you use. Plus, someone else gets to manage the upkeep of the computer. Each cloud provider will have their own selection of services to choose from, but the basic services provided by all cloud providers are compute power and storage. Compute power is how much processing your computer can do. For example, when buying a home computer, you may choose a computer with 8 GB of RAM and the latest processor to run the software you need today. But as the load on the computer grows, you find that it slows down. With cloud computing, you can add and remove compute power as you need it. This saves on costs, since you only pay for the resources you use. Storage is the volume of data you can store on your computer. A traditional computer has limited hard drive space. Over time, you may have to run out and buy another hard drive to store more data. With cloud computing, you can request more storage as you need it. Cloud providers manage the upkeep of the computer, so you don't have to. They will make sure that there are backups, that the operating system is up to date, as well as making sure that everything is up and running 24 hours a day. So as your business grows and your computing needs change, you can quickly bring on new computing resources in a cost-effective way.
Did you like that? I put that video together all by myself right before this.
Wow, nice. You're
Yeah.
pretty good with animations.
I'm wonderful at animations. No, that video was done professionally. So anyways, a lot when that video was talking about like adding hard drive space and adding compute power, that's coming in the IaaS, the infrastructure as a service. And you can actually buy things such as a virtual machine, I should say rent things, such as a virtual machine, which does that for you. Whereas when we get up to platform as a service, that's still kind of there, the infrastructure portion where you can get add more horsepower, if you will, to it, but it's not where you're controlling it directly. And yeah, but I don't know, Alex, when's the last time that you went on and actually bought a hard drive for your computer at home?
It's been a while. I mean, obviously I bought one when I built the computer, but in terms of adding storage or buying additional hard drives since then? Not often.
No, it's been like since probably the early 2000s or like the late 90s for me. But yeah. Anyways, that's because I don't like take any photos or anything. I just remember everything. All right. So the cloud models. So these are like different types of there's different ways you can use the cloud, and that's what we're talking about here. And there's three large ones that you can do. You can do private cloud, you can do a public cloud, or you can do a hybrid cloud. Now, the private cloud is still the cloud, right? But it's yours and yours only. Like, so it's segmented out. And so you have everything for yourself. And then with the public cloud it's like Azure. Azure is a public cloud. So you're saying, all right, I'm giving it Microsoft is going to control everything for me, and you're going to have other people on it as well. It's not like saying you're going to be sharing a bunch of resources, although you might be doing that. When I say resources, like the compute power and all that, but it's being maintained by Microsoft or a different cloud provider. And the hybrid cloud is a mixture between the two of those. So you might have private cloud or on-prem, if you will, and you might have public cloud, and then you're using between the two of them at the same time. So it's kind of like you're lifting and shifting, and you're slowly going over to Azure, if you will, the whole public cloud worth of things. And so then there's one more thing, Alex, and that's the hybrid cloud. So let's talk about this a little bit.
Yeah, so the hybrid cloud obviously provides a lot of flexibility. So it lets organizations choose where to run their applications and which ones to run in which places. And it gives a lot of control over compliance or legal requirements and security issues. So maybe you work in an industry where you have really specific requirements, whether that's healthcare or government. And obviously the public cloud can work in a lot of those contexts, but some organizations still choose to keep certain things on-prem or behind their own walls. And so the hybrid cloud can help with situations that have a lot of specific requirements like that, but situations where you still want to leverage a lot of the benefits and resources of the public cloud. It seems like every organization has their own requirements for different things, and hybrid can really help with all those different situations.
Yep, absolutely. So it's 2-in-1. And the other portion where you have, I guess, 2-in-1 or 3-in-1 or 4-in-1 is the multi-cloud. So let's take a scenario where Google, Amazon, and Microsoft, GCP, AWS, and Azure. It's entirely possible that you might have applications running everywhere all at once. And that's perfectly fine. That's a legitimate thing that people do for different reasons. One's for backups, one's for just because the way applications go is that, as we know, that as you develop, sometimes different decisions are made and you have to put things elsewhere. And a way to do that, or a way to manage things, is through a product called Azure Arc, which helps you manage both multi-cloud and then hybrid cloud, and even like public single public cloud as well. So all these are perfectly valid options on the way to go, where you could have just private cloud, which is your own on-prem. And like Alex mentioned, there's reasons why you would want to do that for like data sovereignty, or going full on public cloud, which is just pushing everything into Azure, and then multi-cloud, where you might have different things on different Azure or different cloud providers as well. But the Azure Arc is like this thing that sits over the top. It's like an abstraction over the top that helps you manage your cloud instances. All right, but how are you going to pay for everything?
So yeah, there's some different types of expenses to consider here. And for the most part, the cloud uses kind of a consumption-based model. So there's fewer or no upfront costs. You don't purchase your own infrastructure or a lot of your own hardware. And you have kind of this ability to pay for resources as they're needed, as you want to scale up, as your organization has more requirements. And then you can just kind of make those go away or stop paying for them when they're no longer needed. And a lot of businesses think about this in the context of like capital expenditure. versus operational expenditure. And with CapEx, if you want to call it that, a lot of times you have to make a big upfront investment in a lot of hardware and set up your own data center or your own infrastructure like that. And because of that upfront cost, that can be a lot initially, and then you kind of take advantage of that over time. Whereas a lot of the cloud models take more of an operational expense approach where you kind of just pay for service and products as you need them over time, and you can kind of add things and take things away, often instantly in some cases as you need them.
Yeah, and sometimes this also leads to unexpected expenses. But let me say, if you do get some unexpected expenses, that I guess that means you're doing well because you have the infrastructure up all the time and you're really using it. And what's cool, at least in Azure, there is a cost monitor that helps you plan out your costs as you go along. And so you can kind of track them through the month. And you can actually also have it set up alerts. And so, let's say, hey, Alex, you're going to spend $100 on, let's say, Azure SQL this month, or, something along those lines. And so you can keep track of them. But with the consumption-based model, you do, you're paying for them as you go along. And some things like serverless, where you spin up from zero and you go higher as you use it, you do have to kind of watch what you do spend, but it has that lower cost than the capital-based expenditure, as you mentioned, where you're shelling out for a huge server farm right in the beginning. So
yeah, and as long as you take the time to set up those alerts and set up your monitoring dashboards or make sure to check those, you can usually avoid unintended costs. So even just for my own use, I have some alerts set up and everything, because I'm always creating things in Azure for content development and personal projects, and I have some alerts set up in case I forget to delete something, or if I'm approaching a certain amount and things like that. So there's definitely ways to control that, and there's a lot of impressive monitoring tools to go all the way down to a pretty granular level to see the costs of things.
Yeah, it's really cool, how you can dig into it. And I'm trying to wonder, on my personal account, I think I might have an expired credit card in there that really kind of cuts it off, so you don't have to use it too much. Use only the free services. So anyways, there are several different, we kind of got we kind of talked about this, is that you can cloud computing overall is like you're getting the services, you're renting the services, like as a pay as you go process, right? And so you can manage your costs, you can plan them out as you were saying, Alex. We can have a whole dashboard, and once we get into the demo portion of this session, we'll show you the dashboards a little bit, and you can put all those widgets, if you will, onto a dashboard and kind of see how they're going. And so that lets you manage your infrastructure overall, especially when you get into like development infrastructure. For production, most likely you're going to want to have everything up and running all the time. But for development, you might want to scale back a little bit if something starts getting expensive. So like right there, you can say like you can scale as your businesses change and do cost optimization. And what's interesting is recently Microsoft put out something called the Reliable Web App Pattern. And I like to think about this as a pattern of patterns. So it's both software development patterns, but also having like infrastructure patterns, and there's one in there for cost optimization patterns as well. So we talk about how to manage costs across development, across production, and what you can do to automatically do it, part of monitoring, part of actually deployment and everything to handle it. So that's actually pretty cool too. It's beyond the scope of what we're talking about here, but we have it in the show notes. I think the link just went up. So yeah, it's pretty cool.
Yeah. I've gone through a lot of that series just to check it out and see what it's like, and it's awesome. And I think you did a great job, so shout out to your involvement in that. But yeah, I encourage people to check that out.
Yeah, it's really cool. Thank you, Alex, for the kind words. There's a link again. We're not very big on brevity here, so we AKAMS/EAP/RWA/.net. I was only a small part. Nish Anil and Ken Schlobaum really put it all together. What's cool about this is RWA, reliable web apps, is just about the first step to the cloud. You can actually think about it as part 2 to what we're talking about today. And then we're going to have scaling your web apps and then modernizing your web apps, which is like cloud native as well. So here we're teaching you what the cloud is. Next step, you can take your app and actually put it on the cloud, make it reliable, and then away you go. Anyways, Alex, we just covered some of the basics. So how about we cover a knowledge check? I'll let you test me on this. We'll see what I remembered. How about
All
it?
right, quiz time.
Yep.
Nice to know here. So what is cloud computing? It's a big question.
Yeah, that's like the basics. That's the question that we want to cover, that we want everybody to come away with from here. And so it could be, let's talk about A, delivery of computing services over the internet. Sounds reasonable, right? That's kind of like the basic. We're going to give computing services. But there's also delivery of storage services over the internet. Now that is like a subset of A. So I would also call that cloud computing. And then there's delivery of websites accessible via the internet. Also, kind of like a subset of A. And the websites might actually use B to deliver some of the content. So what's interesting here is that we kind of went down, like, so C is like platform as a service, B is like infrastructure as a service, and A is just like cloud computing. So really D is the answer. What do you think?
That sounds good to me. Yeah, there we go.
So they're all various versions of cloud computing, and A is like the generic answer, and B and C is kind of dialing it in a little bit, but they're all cloud computing functions.
Yeah. So second question, which cloud model uses some data centers focused on providing cloud services to anyone that wants them, and some data centers that are just focused on a single customer? And
all right.
We have our 3 options that we talked about over there.
Yeah. So not public cloud, right? Because right now we know public cloud is available to everybody. And it's in a question here we see that it's focused on a single customer. And we know when we talk about C on multi-cloud, that means you're using different vendors, which is a little bit different. So when we say single customer, we're not talking about like an on-prem. We're talking a different public cloud vendor like Azure plus GCP or AWS. So what we're talking about here then is hybrid cloud, where we have public and then private cloud that's just focused on one customer.
Yeah, there we go. So another question, according to the shared responsibility model, which we talked about at the beginning, which cloud service type places the most responsibility on the customer?
All right. So here we get to our IaaS, our SaaS, and our PaaS, our as a services thing. And what I really like about cloud computing is everything is as a service. You can have functions as a service, identity as a service, pretty much anything is as a service because it's cloud computing. You're kind of giving it as a service. But I'm just kind of, see, this is where I started the beginning of the show and saying I'm the annoying one. I just start talking. Anyways, so
good.
So anyways, so let's talk about the most responsibility. I'm going to go from the bottom up. So platform as a service really is, here is like a platform that you can develop your applications on. So something like Azure App Service is where you're going to do like web applications. So it almost gives you, if we're familiar with like a Internet Information Server, the old IIS, that is kind of, you can kind of consider that as a platform as a service. There's more, but that's a good way for .NET developers to at least get started with. There's a whole lot more to it, but that's a good way to start at least thinking of it. Now, software as a service is much, much more. Now, if you start, the canonical example is M365. That's the whole thing, software as a service. And there's other things like Salesforce would probably be software as a service. It's like the whole suite of application that is delivered to you. It's coming from the cloud, right? But you don't have to do a thing for it to run other than write the check. So that's software as a service. And then the one that has the most responsibility for you is the infrastructure as a service. You're pretty much just getting the keys to the machine, and the rest is up to you to do. Got it right.
There we go.
All right. So we're going to talk just a little bit now. We talked about what the cloud is. Like we kind of set the baseline here, what everything is. So what we're going to start going is what the benefits are of cloud computing. And so we're going to kind of go over, dive in a little bit more, talking about availability and scalability to it, reliability and predictability, security and governance. We're diving in a little bit more. So Alex, take us in.
Yeah, so a lot of what we've talked about so far is kind of like what is the cloud, and this kind of gets into a lot of the why of why we actually want to start using it and adapting it in our organization potentially. So when you're building or deploying a cloud application, you really want to consider uptime and the ability to handle scale. And so availability, uptime or availability. So when you're deploying an application or a service, you want to make sure that those resources are available when they're needed. So you need to know that they're going to be reliable and that they're going to work as expected, and that if you need more of them, that they're there. And that gets into scalability as well. So another major benefit of cloud computing is that scalability. So, if, like you mentioned earlier, if you're doing really well and all of a sudden your business is taking off and you want your environments to just adapt automatically and handle that, that's where the cloud can really help you, because that's all just kind of built into the fabric of what you're using in a lot of cases, especially if you're trending more towards software as a service or platform as a service. Kind of the further you go that direction, those things are more and more automatically handled for you. But these are definitely two of the big advantages and things to consider when adapting cloud.
Yeah, absolutely. And you mentioned it, Alex, and you did I liked how you put it. You said, like, for success, you want to have things available when you're successful. And a thing that we always kind of talk about when we start talking about availability, at least when we start talking about development, is you want to design for failure. I always like to kind of switch it around, and you want to design for success. So let's say, like, the day after Thanksgiving here in the US is a huge, huge shopping day. And people are going to start really hitting your website a lot. You want to have your website not go down that day. You want to be available everywhere, and you always want it to be up, and you want it not to be slow. You want it to be able to be scalable too. And this is where the cloud helps out, where you're not having to run out to a store and buying an extra hard drive, or adding, plugging in an extra computer underneath your desk or something to keep it up and running. You can just add it very quickly using the cloud, and that's what's cool. And you can have it behind. Going to get a little bit more in depth than what I really should, but like a load balancer, and in different regions too. So let's say you have you're using the West US as where your primary is, and that goes down for some reason. You can have traffic moving over to East US, say, or you could have it balanced. So wherever people are coming from, like Europe or South America or Asia, they go to the one that's closest to them, the web server that's closest to them. And so that's what this is all about. And it kind of gets handled automatically for you. There's a little bit of work set up, but it's way easier doing it in the cloud than it is doing it yourself.
Yeah, I think that's a good point. There's so many parameters you can put around your scalability too. You can choose when it scales out and what the limits of that are, and you can always tweak it to whatever your business case is, because you describe different scenarios there, and that's all easy to set up in a lot of cases, and it just kind of works for whatever area of your business you need it to.
Yep, and you can scale out specific portions too. You don't necessarily need to scale out a database server all the time. You might, but just scale out the web app, so you can kind of pick and choose what you do. So let's talk about scalability a little bit. There's two different parts of it. And I always get these confused, right? So there's vertical scaling. And with vertical scaling, you're taking a machine. It's like you're taking a machine and popping in more to it, more RAM or more CPU. You have your desktop underneath your desk, and you're going to push more RAM into it. That's vertical scaling. You're making the machine bigger. And with horizontal scaling, you add more machines to it. Did I get that right? More processing power vertically scaled.
Yeah, that's right.
Yep. Okay. Good. What's interesting and is, generally speaking, what you're going to want to do is do horizontal scaling. It's quicker and it's less, I guess, invasive to you could scale up another machine. It's not going to take down the one machine that you already have going. So overall.
Well, sometimes horizontal scaling also has greater potential. There's kind of a limit sometimes with vertical scaling, like a CPU can only go so fast, or you can only double or triple computing power so many times. But when you scale horizontally, it's often, almost limitless in terms of how many instances you can have and how many how many different versions of your app can be out there handling requests, things like that.
Yep. That's a very good point. You can just keep on going, whereas you only can add so much RAM to it. All right, reliability and predictability.
Yeah, so reliability, we talked about this a little bit earlier, but that's that ability to recover in those situations where there are failures. So obviously we want to build for success and design for success, but sometimes there are issues or things can come up that create failures. And the cloud can help you a lot with this. There's different uptime guarantees depending on which services you're using. There's things built in to help you fail over to other setups in your cloud gracefully. And this predictability lets you move forward with confidence. So, even if something does go wrong, everything isn't going to go down. We might fail over to a different solution, but it's still acceptable until we get the other one back up. And overall, the cloud just behaves in a predictable way. And that extends to performance too. So we talked about scaling, where we know that, if there is a surge in traffic, that it will be able to handle it predictably and reliably. And that whatever services we're consuming or paying for, that those will behave with similar performance day to day. So you can, on a lot of services, you can actually specify exactly what resources you're paying for or renting, and kind of what the scope of their power and their ability is. And that plays into cost as well. So you're always knowing what something will cost you, as long as you're having predictable performance and predictable behavior on your apps and things like that. So it'll always cost the same relative to how much it's being used in a lot of cases.
Yep. And so I don't know if we're going to get into this later, but I'm going to bring it up now because I'm going to go off script, but it's kind of related, is service level agreements. So this, like the predictability of how much your underlying, whether using App Service or SQL Server or Key Vault, whatever is going to be supporting you, how much it's going to be up. So you always hear like 5 nines, 99.99999% of the time. Yeah, that's pretty extreme. But if you have 99.99% of the time, that's quite often, or it's going to be up quite a long time. So Alex, I'm going to ask you this because I only learned it a couple weeks ago. Do you know how often or how to calculate a service level agreement when you have multiple services running together?
I actually do not. I wasn't ready for the pop quiz on that.
Yeah, me neither. Well, I would never have been. It's top of mind, and I can't believe it that you can do this. All right. So let's say you had an app service. Let's say you had SQL Server, and because it's top of mind for me right now, Key Vault. And one was running at 99.99, the other is running at 99.99, and the other is 99%, right? You multiply those each together, and that's how your overall SLA is.
Okay.
All right. And so since they're each below 1, when you start multiplying them, the number gets lower and lower.
That makes sense.
So
Okay.
what happens then, it's say your manager says, you know what, Alex, I want 99.98 and I will not budge on it. And so let's just say that when those are multiplied together, went to 99.97, sake of argument. How do you get them higher? You add another region to it. And then this is where it gets tricky. So let's say it's 99.97. You add one more region to it, you square that number, and then subtract that from 1, and that's your total SLA across 2 regions.
Okay.
Yep. If you had 3, you would raise it to the third power.
We should have added like a formulas slide in here.
I know we should have. I mean, it's just
math.
Yeah, it's part of the reliable web app series. It's part of the cost efficiency pattern, because you don't want to do too many regions. But yeah, also it gets you that predictability. There it is up on screen. It gets you that predictability, how often things are up, and also be able to predict your costs, because you might not want to have too many regions up and running if you don't need them to hit your service level that your application needs.
Yeah, that makes sense.
All right, so let's talk about security and governance. So governance means essentially that it's auditing, right? So let's say you're running, like healthcare or even like government type work, and that you want to make sure you audit resources that are valid. So like in the US, there's HIPAA, which is like health information privacy, or in Europe, there's the, we had that such a big thing a couple of years ago to do, and I can't remember, but privacy information. You want to make sure things are still compliant, and you could do that with auditing and governance, where things say, you know what, this is going to be exactly what it needs to be for your certain situation. And then with security, you have, it's behind locked doors. Like I've never been to one of the regions, the data centers that we have for at least Azure, but I can't imagine it's as easy as walking through the front door to get in. So there's physically secured, and it's also where we, Microsoft, are taking care of the machines too. So you don't have to worry about any patches or anything like that. And also they take care of the bad actor attacks, like any DDoS or anything like that, is also all, taken care of. Because when you think about it, if somebody's DDoSing your site and it's shared on overall at a region, you want the rest of the region to stay up. So it's in Microsoft's best interest to keep it up. Long story short, governance, make sure everything's regulatory standards, auditing, security, make sure everything is cool. You don't want to have any bad actors hitting it, physical security or anything like that. And yeah, so off topic again, Alex, the other day, last week, just happened to me. I was at the MVP Summit on campus in Redmond. I accidentally wandered into the executive building where like Satya and Scott Guthrie are.
Yeah.
I did not make it very far until like the front desk police came and grabbed me. Like, no, you cannot be in here. So can you imagine what it'd be for an Azure building? So yeah.
So I've never actually been in one of the data centers, but I have driven past a location, and you can tell, even from a distance, that there's security and stuff there. This was actually kind of an interesting one for me because in a previous role, I actually used to work for a large healthcare company. And so there was all kinds of governance questions and governance concerns. And it's nice that some cloud services are kind of, they have certain certifications, or they're approved for certain levels of security and governance and that kind of thing. And so in some cases that can help to offload some of that responsibility and concern. Like basically everything there had really strict auditing rules and all kinds of logging and monitoring requirements. So it was really nice that a lot of this stuff comes built into services, and you can use it to meet some of those requirements in the right context and in the right situations. So sometimes it can be a big help with that.
Yep. I mean, that's great that you can almost offload it to the cloud. All right. So how am I going to manage all this, Alex?
Yeah, so one of the great things about the cloud is that it provides so many different tools and options to manage all of these resources and services. So as we talked about, you can automatically scale up resources, but you can also automate the deployment of those. So if you get into things like infrastructure as code or templating or just different ways to add more instances and scale up your resources as needed, that's all available in the cloud, and it's usually pretty easy to use. So yeah, you can deploy resources based on templates, and that removes the need for manual configuration. So one of the great things about the cloud is that theoretically you can, tear down large pieces of it and then just kind of recreate it quickly and efficiently using templates, and everything will just kind of be set up the way it was, where in other scenarios, if you're doing everything yourself, that might be more difficult to do, but a lot of that comes kind of built into the cloud, and it'll help you with that. And I think one of the most awesome aspects of the cloud is just all the monitoring. So you can monitor pretty much anything and everything in your environment. You can set up all those dashboards. They can track almost any type of data point on your apps or on your network. And I'm kind of that person that likes to go in there and create all the different widgets and kind of watch them and see what's going on. And then you find out maybe you don't need all of those widgets, but you keep a few of them that you actually do use, and everybody needs different things for that. But then you can also configure that monitoring to alert you based on certain metrics, and it just kind of gives you a real-time awareness of everything that's going on. I remember I was involved in a cloud migration a while back, and this was kind of one of the biggest selling points from a business perspective, is just that there was so much increased visibility around everything that was going on in the environments and in the apps. There was some monitoring and stuff that was set up in the original on-prem instance, but so much of this just came out of the box in the cloud and was easy to set up. So everybody loves a good dashboard, right? So
absolutely. I like, you can set them up, have them on your blog. And I could tell when my mom's looking, I get that one view and it's back down to 0, after 30 seconds when she decides it. Anyways, but you do mention something about the deploying the resources based on a pre-configured template. And Alex, you and I were talking about this beforehand, that we have something known as a bicep template that you can deploy resources on, and you can actually pre-configure your templates, your bicep templates, to deploy dashboards all over the place. So that's actually kind of neat, that a dashboard can be considered a resource. So you can monitor dashboards, or your dashboards are monitors that you can deploy. Anyways, it's kind of neat.
I think with Bicep and those tools, you can almost anything you can create in Azure, you can also automate the creation of, which is really awesome, especially if you're in an administrator role or DevOps role or something like that.
Yep. And if you can, a bicep template's a file, and if you have a file, you can put that into GitHub or any other source control of your choice, and so, which is awesome. All right, and so we did kind of get into it. There's a bunch of different ways to perform management. There is the web portal, which we will see when we get into the demo portion of this. There's a command line interface, which I will show off when we do the portal one. So you can actually have a command line interface in the portal, or you can have it just running on your desktop. There's using APIs, which are REST APIs, actually. And another interesting thing is anything you do through the web portal or the command line interface, you can do with a REST API, or using PowerShell, which is a whole PowerShell, I guess, commandlet, do they call it? That it's all Azure based as well. And the command line interface would be AZ, or the Azure CLI, which
I think this list almost kind of illustrates a lot of people's experience with getting onboarded or introduced to Azure, where at first they might kind of poke around in the web portal and create an app service or create something simple, and then as they get more comfortable with it, they might want to start automating things or doing things from the terminal in their development environment, or connecting to APIs in their application code. And it shows kind of a progression of how people might, become more integrated with Azure and more comfortable with it.
Exactly. So what's your favorite, Alex? What do you find yourself defaulting to on a day-to-day basis?
Well, it kind of depends on what I'm doing. If it's just something experimental, or I'm just trying to learn something or test something, I'll use the web portal if it's fastest that way. But if I'm doing something in production, I would probably want that to be done in like an infrastructure as code type of way, where it's repeatable, or it can be done in a reliable or automated way. And then the command line I like to use for just kind of connecting to different services and seeing different things about them while I'm working. So it kind of just depends. I would say day to day I spend a lot of time still in the web portal, but if I'm building an app, then I'll be connecting to APIs and doing that all day. So yeah, it's kind of a cheat answer, but yeah, all of the above, I guess.
Yeah, me too. I mean, most of the time when I'm in the web portal, if I remember the commands for the command line interface, because it's huge, there is a lot, I'll use that. But and the help is great for the CLI. But yeah, most of the time it's in the web portal.
Yeah, I think a lot of people might be intimidated by the CLI when they first start out, just because there are so many commands. But if you actually start using it and get comfortable with it, all the commands have similar syntax and structure. And once you kind of get a feel for that, it's actually pretty easy to use. So I was kind of surprised when I first starting out how much I ended up, gravitating towards the CLI and using it once I had a good feel for how it works.
That's actually a good point. The CLI has the syntax is the same. Like you'll be at home doing something like an AKS versus like ACR. Like it's just the switches are the same. And the same thing that the Azure SDK team has put a lot of thought into is making the APIs roughly have the same feel. So like if you used like Key Vault, everything goes back to Key Vault with me. If you newed up a Key Vault instance, you'll be able to new up an Azure App Config instance. The APIs are meant to feel the same no matter which one you're using, which is great. Obviously, each one has its own tweaks and specifics to it, but they are engineered to be, if you're good with one, you'll be very familiar with another.
Yeah, exactly.
All right, here we go. Now let's check. I am going to ask you the questions this time, Alex.
All right, I'm ready.
All righty. All right. So which type of scaling involves adding or removing resources, such as VMs or containers? So we're adding or removing them to meet demand.
Yeah, so we talked about this, and we talked about how with vertical scaling, you're adding more resources in terms of CPU or RAM or maybe storage vertically, but that doesn't sound like adding more virtual machines or something like that. To me, horizontal scaling, the next one, sounds closer to that. So you spinning up more instances and more copies of your app or your virtual machine to kind of meet demand. And we talked about how that can be almost infinite and gives you a lot of different flexibility and performance gains. So I think it's going to be that one.
Yeah. Boom. Did you see that confetti just go across?
I like that.
Amazing. What is direct scaling? I don't even know what that is. So
in the context here, I'm not sure what that is. I don't know if that's could throw us off here.
Yeah.
Because we only talked about the first two.
Yep. It's red herring. All righty. So what's characterized as the ability of a system to recover from failures and then continue to function?
Yeah, so this is important. We talked about designing for failure and success. This would be for the failure side of it. Reliability certainly sounds like a good option. It sounds like what we talked about. Predictability, that was knowing that our environment will behave the same tomorrow that it is today, and that it'll behave expectedly when unexpected things happen. And then scalability, that doesn't sound quite right. That's more about scaling up to handle more demand, and that's more of a success scenario, right? So I think I'm going to go with A in reliability.
Nice work. Yep.
Oh,
Wow. What's that? It almost looks like snow.
That was
So
fancy.
we're in the springtime now, but yeah, cool. Yeah, we're right. Reliability. So exactly, the available ability to recover from failures. All righty, on to the cloud services. So Alex, how about you lead us into this one?
Yeah, so if you remember from earlier, we had that kind of chart or graph that had those columns, and it had IaaS, PaaS. So that's what we're going to talk more about now, is infrastructure as a service, platform as a service, software as a service, and kind of go deeper into what we started talking about with that shared responsibility. Yeah.
All right. Go ahead.
So infrastructure as a service. This is, you can kind of think of this almost as renting hardware. So it's potentially the most flexible, or gives you the maximum amount of control for your resources, because in this case, the cloud provider is responsible for handling the hardware and the network connectivity and sort of the physical security and internet access and everything. But you're responsible for everything else. So that could be the operating system, configuration work, database configure or network configurations. So everything that's kind of on top of that core hardware layer. So maybe you get a virtual machine, but you're still going to be installing the operating system. You're going to be setting up all the network connections and doing all the maintenance of it. It's just that VM is kind of running on someone else's computer. There's that old saying or that old joke that a data center or the cloud is just someone else's data center, which I don't really agree with, because it's a lot more than that as well. But this kind of gets into that where you're kind of managing everything that's built on top of that core hardware infrastructure.
Right, and so bringing up back this graphic, and we'll bring this graphic up after we go through each one of them. So the shared responsibility is the second column to the right, and it has mostly the customer still is on-prem customer is responsible for everything, but here customer is responsible for everything except for essentially the physical network, data center, and the machine. Otherwise, it's all you. It's all up to you, Alex, to maintain it if you want to do some infrastructure as a service. All yours. So,
yeah.
All right.
No, go ahead.
And say, fill me in. What would I ever want to use IaaS for? I'm responsible for so much. Why would I ever want to use it?
Yeah, so there are a few scenarios where you'd want to use this. So a common one is lift and shift migration. So you're sort of recreating what you might have on-prem. So you're rebuilding your setup in someone else's data center, which can still simplify or reduce some of those either hardware expenditures or some of the effort in just creating that physical infrastructure. And so you're moving your applications to the cloud as is, but now they're running in someone else's data center. A lot of times this is also used as kind of like an introductory move to the cloud. So maybe your organization doesn't have a lot of experience building in the cloud or setting things up in the cloud. So you might kind of start with what you know, and that might be recreating or moving some of your apps to a similar environment, but now it's in the cloud. And then from then on, you can kind of start evolving your app and kind of extracting pieces out to be more cloud native and to take advantage of more cloud services. And I think that's what part of what your Reliable Web App series is covers as well, right? So you're kind of starting, recreating your setup in the cloud, and then from there you can kind of go further with it and start enhancing it and adding new capabilities. And this is also good for testing and development. So maybe you've established configurations for your development and test environments that you want to be able to rapidly replicate. So you can create or shut down the different environments rapidly, but you're still in complete control. So we talked about how Azure provides all kinds of resource management capabilities, and that comes into play here, where you can just manage everything really easily, and it's all running on someone else's hardware. And there's that cloud software layer that helps you manage all of that in a really easy and reusable way.
Yep. And I really like the first step to the cloud, where, you know what, if you're running, let's say, what do on-prem web servers run now? I keep on thinking Windows NT, but let's say you're running, I have no idea, but let's say you're running Windows 11, and you can easily stand up a Windows 11 VM and not make any code changes to get your application up and running. So yeah, there you have it. Lift and shift, run IaaS, and you're really not you don't have to invest in any application changes at all. Windows NT, blast from the past. Who would have thought that I would have brought that up in this session? Katie backstage is probably wondering, what is Windows NT? So what did NT even stand for? I told you I'd go way off subject. I don't know. Next thing. Ask your questions. We'll answer them live. I just asked the question. I have no idea. All right, platform as a service. So this is our next one. This is our middle ground one, right? So we're developing the application here, right? It's one step above infrastructure as a service. We don't know. That VM has been fully provisioned for us. It's running everything that we need it to run. All we need to do now is actually deploy on it. It's not really a VM anymore. It's abstracted for us, and it has a bunch of things kind of pre-installed. Like it can run a container, and all we have to do is deploy the container to it. It has a bunch of monitoring tools already installed on it. We just have to plug into those. So this platform as a service is abstract, or one step above infrastructure as a service. It has a lot of cool things that we can plug into when we're developing our apps, and it's fully licensed. All the patching is taken care of. Like when we're talking VMs, nobody's going to be able to update Windows except for us. But here, if we're running a Windows-based app service, all done. It's gonna go for us. And so, like, development tools connect to it. Super great. Visual Studio, wonderful with app service. Even VS Code works great. Or Azure Functions, which is another. Well, Azure Functions, the functions as a service, but you can think of it as a PaaS. So it's one step above, where a lot of the stuff that you used to take care of, now gone. You're just starting to worry about keeping your apps nice and up to date. So you can really just focus in on making sure your business logic works. Just what you care about, and not anything about on the infrastructure side. And so now we are over in the PaaS column, and you can see the identity and infrastructure management and the applications and the network controls. They're all Microsoft/customer. Now, we were just kind of talking about, like, you don't have to worry about networking anymore. True and not true. So what you can do, though, is you can start setting up your own VNets, virtual networks, as well, to isolate certain platform as a service services if you wanted to. You don't have to, but you could. So, like, you do have all this functionality that you can. Applications, most of this time, that's still going to be on you that you're going to do. You can get some platform as a services where the applications are up and running, but we're developers. We want to take care of that. We want to do that. And identity and directory infrastructure, we could use Azure AD, but ASP.NET has its own identity stuff built in if we were doing that. So that could be on us too. But Azure AD is there. We could use Azure Active Directory B2C, but if you wanted to use Identity Server, you could do that as well. So that's why it's very flexible and doing what you want. But notice that the operating system done by Microsoft in this case. So
yeah, I like what you said towards the end there, because I always think of platform as a service as you care about certain configurations, but only the ones directly related to your app. So you might care about, some of the incoming or outgoing network connectivity to the app, but you're not worried about the underlying operating system or its, core connection to the internet or anything like that. Like, you're just worried about some settings that directly affect your application. And the cloud can also help simplify how you apply those configurations.
Exactly. And that's, yeah, I like how you phrase it there. You're only worried about what affects your application directly. So if you need to make some tweaks because your app demands it, you're free to do so. But if your app is like, cool, I don't care, I just want to run, you don't have to.
Yeah.
So, all right. So some past scenarios, pretty much when you're a .NET developer and you want to create a .NET web application, app service, Azure App Service is a way to go. So there's a lot of text here, and I don't want to read it all because there's a lot there. Oh, they're comparing it to Excel, where it runs on Excel. But yeah. So essentially, what it is, App Service, you can set up scaling rules where it'll scale for you. High availability, where we don't want it to go down at all, has like that 99.99% availability. Boom, you don't have to worry about all that stuff. It just works. And as Alex was mentioning before, you can get a lot of insights coming out of this. It's really easy to hook up to another product called Application Insights. In fact, all you have to do is kind of flip a switch and it starts working. You can get a ton of analytics coming out without even having to set up the Application Insights SDK in your application. So just by kind of flipping a switch in the Azure portal, you start getting just a bunch of information coming out. So this PaaS scenario where things are just kind of set up and running works great. So yeah. Now let's talk about the one where you don't have to do any work at all. Alex, software as a service.
Yeah, so sometimes people don't want to bother with any of those mid-level configurations. They don't want to set up their own applications. They just want to essentially rent or pay somebody and just get access to a fully developed app or a suite of apps. So Microsoft 365 is kind of the classic example of that. So this is just ready to go. You just pay for a subscription, you have an account, and that opens up all kinds of services and possibilities. And sometimes these are so ubiquitous that people can almost forget that they're using the cloud. Like, you just kind of go into your browser and start using a site or start using a service, and you don't really think, oh, I'm using the cloud, or you don't necessarily think about that in the moment. A lot of people think about the cloud as like logging into the Azure portal or creating a VM, at least if you're in the IT side of things. But cloud services are everywhere, and software as a service is used by almost everyone. So this can encompass so many different things.
And there's actually, as you're explaining it, Alex, where you don't really think about it, there's a consumer side like Microsoft 365, or even like things like Dropbox, our software as a service, fully packaged, you don't worry about them. But there's also like APIs that can be considered software as a service. Well, Dropbox has an API to it that you can plug into, and so now you're using Dropbox software as a service, but as an API to get at it. So developers, I guess you're kind of cutting out the UI to several like very popular software as a service products to get at them. So Salesforce, I'm sure, has that. I know I'm forgetting millions and millions of them because I can't think right now. But yeah,
like payment services, all those kinds of things. Yeah,
exactly. Yeah, Stripe would be a great example of a software as a service that has cut out the front end to it, but it's fully configured and ready for you to go to integrate into your application. But pretty much, if you're paying a monthly fee, you're using a software as a service.
Yeah, and so revisiting this one more time, you can see with software as a service, it's really just that top portion that's always maintained by the customer. So obviously, you're always responsible for your information and data, and you're always accessing that from your own devices. And then the accounts and identities, you always want to take responsibility for and be careful with those. There's a little bit of a slice with the infrastructure part there, just because access and identities can encompass so many different things. So there might be some of your own setup, especially if you're like integrating a large software suite with your organization. You might have to do a little bit of that account infrastructure and set up yourself. But for the most part, with software as a service, most of it is handled for you from there down on this graph, at least.
Yeah, that's a good point with the identity stuff. Like you could have your own internal Active Directory, your own internal login model, and then you have to integrate that with somebody else's, like Slack comes to mind,
Right.
where they have, you can log in that way. And so there's identity is really, really tough. So we could have a
Yeah, just from a business perspective, a lot of times that's the first question they'll ask when they're evaluating a software suite is, does it integrate with AD, or does it integrate with whatever identity system they're using? And there's always just that integration piece, but from then on, it's ready to use.
Yep. All right, and then some scenarios. We've been kind of talking about them as we go. Email messaging like M365, or even the Google Suite, our software as a services, really any business productivity, Salesforce, or we'll say Dropbox, Calendly, sure, software as a service. I mean, they're all out there. Finance and expense tracking. We could go on. And like I said, if you're paying a monthly subscription for something, it's software as a service. Even if you're not paying a monthly subscription, it's software as a service. And what's cool is that you can be using platform as a service to build a software as a service to sell to somebody else. And yeah, that's software as a service is a great business model to have if you can get into that recurring billing cycle.
Yeah.
All right, here we go. Now let's check. Alex, it's your turn to ask the questions.
All right. So first, which cloud service is most suited to a lift and shift migration from an on-premises data center to a cloud deployment?
All right. So I'm going to start with, I know what it's not, and it's not software as a service, because you're not going to move and go to a complete, well, it's not software as a service. Yeah. And it most likely isn't a platform as a service, because it's not most suited when you're just going from a pure lift and shift. So infrastructure as a service, spin up a VM, really not much code changes, if any, are needed. Just ready to go, open up a VM port with the IP, put a custom domain in front of it. I'm always thinking web, and away you go.
I was hoping there would be some kind of celebration graphic there.
There we go. I was waiting for it to come on. I didn't see any. I thought, oh, man. All right. So
what type of cloud service or what type of a cloud service would a finance and expense tracking solution typically be in? And we kind of just talked about this, but see if you can remember.
Yep. I'm guessing everybody went right to the correct answer. So infrastructure as a service, no. I mean, the application's already built, right? We're just going to skip right to the right answer. It's going to be software as a service here. And wow, stars for shooting out into the universe. So now, Alex, now that we're all done here with this portion, and we were talking about the lift and shift before, what do you think? It is entirely possible, and it might be worthwhile, that you would lift and shift and just get rid of your application, just go right to a software as a service. That is a possibility of something you might want to do and consider, if it's cheaper than maintaining. Because software as a service, you get all the benefits of the cloud, where you get the cost predictability, you get the high availability, and everything else. It's up and it's running. That is something you might want to consider. It's just throwing that out there if it fits your needs. Like, you're not going to run a clone of Dropbox.
Yeah, I mean, sometimes this is framed as like the build versus buy conversation. Yeah. So, every business will have some kind of need, and depending on how specific or how niche that need is, or how customized it has to be, that's when they kind of evaluate, should we try to build this ourselves, or should we just see if there's an out-of-the-box solution we can buy that will meet all of our needs. And there's a million different scenarios where that might apply, and so everybody has to make that decision and that analysis to come to what's best for their organization.
Well said. So going to Q&A, if we have anything, I don't know, but we should be. Katie, welcome back.
Hello. We don't have a lot. There's some interesting theories about Windows NT, but yeah, we're a little light on the questions. So please feel free, anyone, to pop those in chat. We're surfacing some of the theories here. But otherwise, I think we can get into our next demo.
All right. So I quickly wanted to run by these, and we'll put them in the show notes too. What Alex and I ran through were actually 3 different Learn modules, and we put them all into one. And so the first one was describe-cloud-compute. The second one was describe-benefits-use-cloud-services. And the third one was describe-cloud-services-service-types. And we'll have all these in that link that Katie is showing at the bottom of the screen right now. Yeah. So cool. So we have the second then, Alex. So we had this module, and we have another one coming up, and 2. Here we go.
Let me pop in real quick. We do have one question coming in. What does the term serverless mean?
Oh, functions as a service. Alex, you want to take that one, or you want me to do it?
Sure. I mean, we can tag team it. So serverless. So the question was, what does serverless mean? Am I getting that right?
Correct. Mm-hmm.
Yeah. So serverless is a little bit of an overloaded term sometimes, but basically, serverless means that it abstracts away like a lot of the infrastructure or setup required to service requests. So Azure Functions, for example, can offer a serverless infrastructure where you can essentially just kind of write and deploy pieces of code. So kind of like individual functions or individual little endpoints to service a need. And different cloud providers have different implementations of this, but it basically means like you don't even need to have a full application deployed and running, because even that part of it is handled for you. You're essentially just writing small pieces of functionality that handle specific requests or specific needs. And this can be used for all kinds of things. Like maybe you have an application that just needs to make a request to do one thing, and you don't want to spin up a whole application just to service that one need. So instead, you'll use like a serverless approach where you just kind of write a simple function that handles that. Serverless can also be really big for integration. So say you have 2 apps that either need to talk to each other, they need to hand something off. Sometimes there's kind of like an intermediate function there that'll just handle that one task. Matt, do you have anything you wanted to add to that?
No, that's a really good explanation, Alex. Yeah, and I like the fact that you said it doesn't necessarily mean to be a full application. Like, so if you're writing a .NET Web API or a .NET Web site, it's logically going to be something you're going to have middleware, and it's a full app. Where serverless, even though it still has a CS proj and everything in it, it's individual functions that do something. Right. And so then there's 2 more parts. So you're just concentrating on these functions. These functions really are self-contained, and they do one unit of work, and they're meant to be called to do one unit of work from an external source. They get triggered by an event of some type, and they do one thing, and that's it. So they're not meant to be called by another code function, if you will. They're meant to be called by an external source, do something, and done. Now, what's cool then is, first off, is that they get called by this external source. So whether that can be an HTTP trigger, it could be something getting inserted into like a Cosmos DB database. It could be a blob getting entered. It could even be a road a row getting changed in Cosmos or a queue item getting changed. There's a bunch of different triggers that get hit that start this Azure function, and you get the full information about what caused it. So like in a queue instance, an Azure storage queue gets changed, you get all the information about that queue row item that changed. So you get all that stuff coming in and you can act on it. And then there's also bindings as well. So let's say you wanted to write to Cosmos DB. So you create an output binding to it, and all you do is just say return object, and it automatically writes to Cosmos. And you don't have to new up anything to it. The function's runtime takes care of all the writing for you. And this works with table storage, it works with queue storage, it works with things that I won't remember right. Signal R, you can do a whole Signal R hub, things like that. And serverless means you can scale it down to 0. It'll go away and you don't have to pay for it on the consumption model, which is by itself. And then it scales up to as many instances as you need by itself. And so that's cool. There's another model for it where you can kind of pay for reserved units already, but on a consumption model, serverless goes away. So that's cool. That's generally what I think about when serverless is talked about. Azure Functions, we kind of explained that a lot, but there's also Azure SQL serverless too, which serverless means the server does go away and that you're not paying anything if you're not using it.
Yeah, like just as one other example, so I actually worked on a project once where we used serverless kind of in combination with a software as a service solution. So we talked about how you can just kind of pay for software. So in this case, it was a software as a solution service that was for like surveys or feedback and stuff like that. And as part of that package, you could plug in an API endpoint that it would kind of send data to, and you just needed an endpoint to collect data. And so we used like a serverless function that would just kind of aggregate data and save that somewhere out for reporting and things like that. Like that was an example where we didn't need a whole application spun up, or we didn't need, a full VM or something like that. We just needed some code to do something in response to something else. And that was a good use case for serverless. So those kinds of scenarios, something to think about.
Yep. And I did mention that serverless was, or at least Azure Functions were meant to run alone and by themselves, which is true, but you can have things like they hooked up so they get chained. So like you could have one respond to a web request, which enters a row into an Azure storage queue, and then have another one that picks up the Azure storage queue and does something to a blob storage or something. So you can make them so they chain, but they should be self-sufficient where they're not dependent upon anything else happening other than the event that kicks them off. There.
Great.
Hope
Well,
that answers
thanks for the
question.
question, and thanks for the very thorough answer. That's all. That's awesome. That's all the questions I'm seeing for right now. So I'll hand it back to you both, and I may pop in if a couple more get asked.
Sure. Yeah.
All righty. So Alex, let's start talking about publishing now, web apps to Azure with Visual Studio. So we talked about everything about the cloud. Now let's actually use it. So let's tell us what we're talking about here.
Yeah. So for this, we're going to be, well, first we want to make sure we have our environment set up. So Visual Studio has all kinds of powerful integration with Azure. So does VS Code, if you prefer to use that. But we're going to be looking at Visual Studio, and we're going to make sure we have that properly configured. And then we're going to look at creating an ASP.NET Core app. And we're also going to look at Azure App Service and see how we can publish our app up to that service, and then explore some other things with the project and maybe update that app and redeploy it. So be a lot of fun. Let's get started.
Yeah. All right. So here's what we're going to do. Imagine your PowerPoint skills are so great you can come up with a slide like this. First off, PowerPoint's great now. All you have to do is like do something and it suggests everything for you. And you get this. Yeah, it's so cool. Anyways, so imagine that you're a software developer working for a ski resort. See, look at that, I got stars going on and everything. And so what we're going to do is we are going to kind of sort of build an application that lets users view trail maps and purchase lift tickets. But what we're really going to do is just build a web app that we deploy to Azure, and we'll change it up a little bit to so we can redeploy it to Azure. So long story, we would do the whole thing, but here just for this session, we're just going to get it up and running and push it out to App Service. But this slide though, wow, amazing.
I do like the slide, and we
Yeah,
can also,
it's good looking. Anyway.
I'll just quick mention the reliable web app series that actually does get pretty deep into actually like building every piece of this and kind of going more in depth with code and infrastructure deployments and just kind of the works. So
yeah, for sure. You know what? Once we get out to the web browser, I'll bring it up too, that URL, just so you can see everything that it does. It's crazy time, but cool. So Visual Studio works great with Azure, works great with ASP.NET, as we all know, and together they work together better. And what I like about Visual Studio working with Azure is that you don't really have to leave Visual Studio to get out to Azure. There's a bunch of you can debug on App Service. You can do, as Aaron Powell likes to say on my team, click ops, where you right click deploy to Azure if that's your thing. That's like the step before DevOps, I suppose, before you set everything up. Anyways, long story short, there's 2 workloads though that you do need to install. The first is ASP.NET web development workload. And so what workloads are in Visual Studio, when we released, I think, Visual Studio 2019, instead of installing the full thing at once, we have it broken down into options now. Now you can just say, hey, I just want to do ASP.NET web. And so you just download that workload or the tools necessary for that. So for ASP.NET and Azure, you need these 2 workloads. So if you're going to do game development or if you're going to do MAUI development, you would have additional workloads for that. But here, this is what you would need for this stuff today.
Yeah, I'm actually a big fan of the workloads because when you're first setting up Visual Studio, they can really trim down the install size, and then you can kind of just install the core product, and then as you need more pieces of it, you just install more workloads. So I personally like that a lot.
Yeah, and did you know, going off track, in .NET 8, there's going to be a new .NET CLI that's .NET Workload Clean. They're like, if you have just a bunch of old workloads sitting all around, like from previous installs, that you can just that gets rid of them for you.
Yeah, I heard something about that, but I have not actually tried it yet. So
yeah, me neither. But I did. I'm going to give it a shot because I have just tons of old Visual Studios that I need to clean up.
Yeah.
So when we're installing Visual Studios, well, you know what? We'll show this. Alex, you talked about this a little bit, how it's there. Easy to install, and I'll show what it looks like when we get into the demo real quick. So how about we do that? How about we just jump right into the demo and show what all these words and the slides look like. All right, so let's crop this out. You can see my screen, hopefully, and I'm going to load up. Let's do Visual Studio Installer.
It's consistent with the skiing theme, the mountains back there.
Yeah. Oh, I didn't even think about that. Good call. Installer. Open it up. All right. Here we go. And so what we're going to see here is different ways to install Visual Studio as soon as this loads up. And usually it doesn't take that long, so I must have a lot of things running. And I have both Professional 2022 Preview and Regular installed. And then if I wanted to change what workloads I had, I would just click on Modify, and then it would show me the different workloads available. Come on. Wow. My machine, actually, I have one of those Windows Volterra devices, ARMed machines, and it's super great. It works great, except I guess when
I don't want to try those. Those are cool.
It works good for me. I don't know, except now. But so here's where the workloads are. You would just click on that. Web development. I have MAUI installed here in Azure. You know what? Azure is actually not supported on ARM yet. Oh my. But if you're not running the particular device, you can install the Azure workload. We'll still be able to get away with it though for this demo purpose. So yeah, not everything's ready yet. Let's look to see if it's in VS 2022. No, that was preview. It would have been there. So yeah, interesting. Anywho, there we go.
Yeah, and as kind of a side note, over on the right there, there's more details about what's
Yep.
going on here with these different workloads and what you're actually installing and what's already installed.
Yep. So you don't have to install the full thing if you don't want to. You can pick and choose. All right. So let's close that out. We're going to open up Visual Studio proper. I'm going to close the application that I had open, close solution. And while we do this, what I'm going to also do is that we are actually doing this Learn module at the same time. So we're going to take everything that we have and come on, dock it. No. There we go. And what we're going to do is, where's my Visual Studio go to? There it is. We're going to go through the exercises that this particular Learn module that we're talking about has. So the first one is pretty simple. All we're going to do is build an ASP.NET Core project and run it. So all we're trying to do here is show off basics of that we don't have to do anything special to get an ASP.NET Core project up to Azure. So I will just do, how about ASP.NET Core Web App? We'll hit next. We will just call it, what should we call it? Let's Learn Live. How does that work?
I was going to suggest something with the skiing theme, but I couldn't think of anything.
Let's Learn Live Ski.
Let's ski live. How about that? No.
Oh, nice. Nice. Let's ski live. All right. Going to save it on the desktop. Solution name is Let's Ski Live. We'll hit next. We will run .NET 7, the latest and greatest. No authentication because we don't care. Everybody can use it. And we'll use top level statements. Let's create it. While it's spinning up, we'll leave this open for just a second, this welcome screen. And I'm going to go in to our pages. This is our program file. This is all normal stuff, you know, right? It's file new. We just file newed it. There's nothing here. Let's open up the index CSHTML file. Looks normal. Let's run the app. Debug it. Hit it, spinning it. Come on. And here we go. Which web browser is going to open in?
I always use the Visual Studio dark theme, so I almost forgot what it looks like with the brighter.
You know what? I go with light theme during the daytime and dark theme at night. I'm very peculiar. So anyways, Let's Ski Live. Home, privacy, nothing to it, right? Basic of the basic. And yeah, that was a pretty easy demonstration. Lots of coding involved. It's pretty much all I can handle. Let's see, might notice a section at the top, except that's it. That was pretty straightforward. Best demo ever.
So far, so good here.
So far, so good. So really, all we're demonstrating here is that it's just a file new application. Yes, got the sparklies out there. That file new app, we're not doing anything special to Azurize it eventually. All right, so back to the slides. I'm going to close that one. Shift F5. Swap my displays. All right, here we go. So Alex, what's going on with Azure App Service?
Yeah, so we created our application, and now we want to deploy it out to Azure. And one of the most popular options for that is Azure App Service. which is a really easy to use service for hosting web apps, REST APIs, backend services. There are some options for other things like some container scenarios and things like that. But it's a pretty flexible service that can do a lot of things, and for a lot of people, it's kind of their first entry point into hosting on Azure.
Yep, it's one of my favorites. I think it's a great service because it has just a ton of things in it, and there's plans that go along with it, and we mentioned those plans before. The number of, I guess, the horsepower behind it, like how much RAM is involved or the CPU resources. Those are the plans. You can have it even where it's isolated overall, where nothing can get at it. There's even a free plan as well. So it's like it's not going to be super fast, but it doesn't cost anything. And so there's a bunch of different ways you can specify your app service, including the region where you want it to live. So you can have it like I'm over here in Seattle, so I would want my stuff living in West US. Well, at least while I develop, because it's going to be quicker. Whereas when I deploy it, it's where I think the most users are going to be at. So,
right.
Yeah.
Yeah. So, and with that comes different pricing and reliability levels. So you can basically, pay more for more services, more resources. So we start with free and shared, which are kind of those base tiers. And those run on the same VM as other app services, even with other customers, though obviously there are security configurations in place. So this allocates CPU quotas to each app that runs on those shared resources, and there's pretty limited scaling options here. These can't really scale out much. But free and shared are really more for experimental use, or just kind of getting started with Azure, or testing things out, or if you want to quickly deploy something just to see if it's running. But you really wouldn't want to host like production scenarios or anything that is really important to you on these options, because you're going to be kind of limited with some of these configurations.
Yep, and it cannot scale out. That's a good point there. So you're not going to want to go too crazy with things. And then you got pricing and reliability levels. And so obviously free is going to be free, and you can go up in pricing as you go. So basic, again, just a little bit above free. And as you go all the way up, you get to premium V2, which really are, you're running app service runs on VMs, but you get the abstraction above it. And when you get to like that premium V2, nobody else is running on that VM. It's yours. You're the only application that's running on that VM. So you got a whole bunch of power behind it, but it's going to cost you more, right? And so when you get up to that level, you're going to want to make sure that you can justify that cost. So it's a give and take of where you want to have your app, and that's what you're getting at here. Is that generally, it's standard probably is going to be the best for you, but if you really are getting into the big time, let's go to premium V2. Let's get you what you need, and that's the point. There's going to be something here that's going to fit your work level.
Right. Yeah, and there's even isolated. So this runs on a dedicated Azure VM on dedicated virtual networks, and that second part is important. So you get both compute isolation and network isolation here. And this provides maximum scaling capabilities. This is for resource-intensive apps, if you have a lot of different scaling needs, and if you need resources across different geographical regions. So when you're evaluating this, you kind of just want to look at the requirements of your app, compare that to what each of these tiers offers, and then pick the one that seems like the closest fit for you.
Yep. So let's do it. Let's get our app that we just created, our skiing app that does trail guides and lift tickets, and push that out to, wow, where did that come from?
We're getting more elaborate as we go.
Oh, amazing. Let's get that out to app service. All right. Windows Defender may be impacting your debugger start time. Wow, look at that. Anyways, let's open up. Let's see, where do I have it? Right here. All right, over here. I do have Windows portal open. So you can actually deploy your web app. We're going to look at it through here. I can do right click. I can do publish, click ops. And I could say, hey, where are you going to publish today? I want to publish to Azure. I can do next. And I say, hey, where do you want to publish to? And there's a bunch of different, hopefully everybody can see this. It's a little bit small. I can say, hey, I'm going to publish to Windows App Service. You can say next. And then as I say, what subscription do you want to publish to? And it's going to give me various resource groups that have an app service in there. I could create a new one here. I want to show you how you do it from the portal. So I'm going to hit cancel. I'm going to hit cancel. Let's open up the Azure portal. Here.
Yeah, when we looked at our tool slide, we didn't put Visual Studio on there because the other tools are kind of more agnostic to different scenarios. But yeah, Visual Studio can do a ton of stuff with Azure if you really get into it. It can provision and manage resources in all kinds of ways. But
yep,
we can.
You can monitor your app, so you can actually see you can see analytics come through and a bunch of different things that happen. So actually, let me see if I have it in my dashboards. Oh, right here. Let's see if it's working. Oh, it's not there anymore. Alex, you would have loved it.
Did you build some epic dashboard?
Look at this. Look at this thing. Talking about dashboards.
Yeah, this is the kind of stuff I love to watch.
Yeah. We're not going to be building that here, though. It takes a while to put all that together. But anyway, let's go back to my resource groups. And what I'm going to do, I'm going to open up the CLI, which is down here. And it's doing a PowerShell. So I can run, this is the Azure CLI running within the Azure portal. All right. I could run it locally as well. But when I run it up in the Azure portal, I just have a ton of tools that are available to me that I don't have to necessarily install locally. Come on. My goodness. Here we go. So, building. All right. So I can do things like docker -- help. And this has Docker installed by it. I could do, wow, that just looks terrible, doesn't it? I could do something like GH. That's the GitHub CLI. So that's installed too. So I could go get things from GitHub, run Docker on it and everything. So it's all there and it's all up and running. I could even switch over to Bash as well and have that there. So I was running PowerShell before. Now I'm running in Bash. Cool. And there's AZ that we'll be running now. It's the Azure CLI.
Well, it's also worth noting that it auto signed you in and took care of the authentication piece for that. If you're doing it locally, you do have to log in through the CLI and everything, but it knows who you are in this environment here.
Correct. Good point. And so what I'm going to do here is do AZ group create -L West US -G RG let's ski. So what this is AZ is the Azure CLI. Group means resource group. Create means create. -L means location. -G in this case means group name or name. And RG let's ski means let's ski, the name of it. So I'm using the Azure CLI to create my resource group. I could, let's actually do it. Assuming I remembered everything correctly. Come on. Usually it is much faster. Maybe I have to be at the end. Enter, here we go. And boom, it's there, created the resource group. I could have gone through and did a create, oh, not a dashboard. Resource group up here and did a create resource group there had I wanted to. But I wanted to do it by hand just to kind of show it off.
Well, that's an example too of once you're comfortable with the CLI, it can actually be faster because you just type out, 4 or 5 words and hit enter, and you can create your resource group. And
Exactly.
the command that you showed there, the structure of it applies to a lot of other things. So it's kind of like it's almost like a noun verb type thing. So you had your noun of group and then create, but you could substitute other services for create there as well. Like they'll all, follow a similar pattern.
Yeah. So let's do az-help. How about az-help? And let's see, these are all the nouns. So like there's ACR, advisor, and then a app service. So let's do AZ app service -- help. These are all the things I can do with app service. And there will be come on. Oh, went up too far. How about I just do this?
There you go.
Oh, there it is right there. So I can do AZ app service, like list locations, plan. And so there's a long story to it, but I need to create an app service plan before I can create an app service. Long story, but let's create an app service through Visual Studio. I already have a resource group created. All right, back to Visual Studio. Make this larger. We'll add a publish profile. This is the same as right-click, publish, Azure, next, Azure App Service, next. It's going to look through my subscription to see if I have any app services created. I only have this one. I want to use a different one. Next.
And just real quick, you logged into Visual Studio here, so your name's in the upper right there. I just want to point that out. That if you basically log into Visual Studio with the same account that you would log into Azure with, and a lot of this will just kind of auto sync for you.
Yeah, thank you, Alex. And you can do that through the file menu. If you go to the file, there will be an account option there that you can use to log in.
Yeah.
All right, so we'll use Let's Ski Live, and I'll give you a suffix it by the date. We'll just accept that. And then we can pick the resource group. And the resource group, we'll just pick the one that we just created. So pick that up. And then we'll have it pick a new plan for us. We'll just do what it suggests. And we could pick other ones that we have here. Oh, you know what? Let's do this one. Let's Ski Live. The little asterisk says it's a brand new one. Or we could go through and actually specify what we wanted to. But for time's sake, we'll just take all of these. Create. And so all this is doing here is creating a publish profile. It's going to create the publish profile and provision the app service itself. As we go through, and it does take a little bit to go out and create the app service depending how busy things are. I'm using my personal Microsoft account, and we are actually lower down on the list to make sure customers have the best experience, which makes total sense. So sometimes this takes a little bit longer to go through. And here we go. So it says, do you want to publish to that one? Yes, I do. I'll finish it. And then it's creating the profile, which is really just an XML file for me.
This step can kind of trip people up because it's not actually publishing the app right now. It's creating the file that will determine the publishing process.
Correct.
So a lot of people get here and think that it was deployed, but there's that button in the upper right there that you actually have to push.
You have to push this. Exactly. So let's push it. And it has like all these, like it's saying you're going to do a release config, net 7 and all that stuff. So let's do push it.
Yeah, and this file lives in your Solution Explorer over on the right. So this is like an actual XML type file. So if you go down in the project, you can always get this file back. Is my point? Like it goes with your solution, so you can reopen your publish settings later for this.
Yep. And still publishing.
I think if you open your output, it also gives you a more detailed information.
And here we go.
So it'll kind of tell you the different steps that it's taking care of.
So we built it, we did publish it, and then it automatically opens up the website of where we published it to. Let's ski live. We're out there. Yay us. Look at that.
Wow.
Wow. I didn't even put that GIF in there. Wow. Katie is killing it backstage. Wow. All right. So let's move on to Shift F5. I have to figure out how to make my display work differently. But all right. Alex, explain to me what Razor pages are. We're going to go through what the Visual Studio file format is, right? So how about we just go look at all this? You know what? Let's just look at Visual Studio.
Yeah, it might be easier to just look at the Solution Explorer here.
Yeah. So let's see if I remember. What setting is it? Font, system fonts, right?
You can go into the settings for your fonts, and I think there's like different font settings apply to different parts of Visual Studio. I don't remember what the global one is. So if you go into options and down to fonts or
font. All right, it is.
So that's your text editor. I don't know if you might want to try to see if there's this like Solution Explorer or Windows or something.
I think it should be under
environment.
Text editor is the top.
It might be environment. I can't remember which one controls the Solution Explorer.
Yeah, let's see, environment.
It's further down. There it is, right in the middle.
All right, it's not letting me change the size. Let's do, how about Arial? Good. How about 14? Okay. Hey, there we go. A little bit bigger. Hope everybody can see it. Let's
maybe bump it up a little more.
Options. Let's make it 20. There we go.
There we go.
Hopefully it's a little bit better for everybody.
Yeah.
If not, trust us. Okay. So go ahead, Alex.
So let's talk about the project structure here. So this is a pretty standard ASP.NET Core Razor Pages project, and the giveaway for that is the Pages folder. So if you expand that, that's where most of the application source code will live. So Razor Pages uses kind of a two-file approach where you have your one file that includes your HTML and your Razor markup, and then there's a code behind file with your C# logic that powers that page. So this might be familiar to a lot of people if they've used this structure before. There's also the MVC model, but Razor Pages are often nice for just getting started with something that's a little bit simpler. So further up, we have the www root folder, and that's where your JavaScript and CSS files will live, and those get included in your project. These ones are already included automatically. And then you have the lib folder for any additional packages. App settings down at the bottom, that's where you'll control a lot of your application configuration. So if you have a database locally, you might put a connection string in the development file here. But in your Azure environment, you'll want to keep that connection string somewhere secure. The program CS file down at the bottom, this sets up kind of the essentials of the application. So two of the main things it'll do here are configure your middleware pipeline. Middleware kind of forms the essential building blocks of your app. So your routing, your authentication or authorization, serving up static files like JavaScript and CSS. You're just kind of constructing that middleware pipeline for the app. And if you're not too familiar with middleware, don't worry about that right now. It's not too essential for just getting started with something simple like this. But this is also where we register services for dependency injection. So up at the top, there's that comment that says add services to the container. That's the DI container. So this program file is just where you modify kind of the core services and building blocks of your app. But most of the time when you're working with Razor Pages, you'll be in that Pages folder actually building application logic and building, the real functionality of your app. The rest of this is kind of just configuration and setup for when you need it. So yeah, maybe we can modify something here and deploy a change out or something like that.
Yeah, let's just do. How about let's ski? My closing tag, P. Let's modify the privacy too. All right. Run it locally. We'll debug, make sure it changes. Oh, that's fine. Do you want to continue? No. Come on. Here we go. Let's ski. Privacy. Shh. Let's redeploy. Right click. Publish. Hit that publish button.
Yeah, so it remembers the publishing profile that we set up previously, and now we don't have to go through that whole dialogue. It actually remembers like which app service to deploy to and some of those essential settings. So redeploying is much faster than the initial deploying now that it's all created and set up.
Correct. So it's building, it has to push up my DLLs. Maybe get it open again. And here it is. Let's ski behind the sweater. And then, shh. All right.
Well,
we did it.
And what's cool here is that Visual Studio and Azure kind of work together to figure out a lot of things for you. So if you notice, like you deployed a .NET app, but you didn't really have to do a lot of configuration of saying, hey, this is a .NET app, so I need all this set up or I need all this installed. It kind of just figured out, what type of app it is and what app service settings should be in place for that to run successfully. Yeah, and if you go through the Azure portal here, you can see some of the settings that were applied. Some of them are defaults, some of them were adjusted for your specific app and so on. And then you can start to tweak things in here as needed.
Yep, and you can have the application settings, which are your app settings, .json. You can see that we went to .NET Stack as opposed to Node or Python or whatever. You're running on 7. That's stuff that all got set up for us. So that's cool. And we can have it set up so we could have GitHub Actions deployed to it, or deployment slots is even more interesting. So we can actually deploy to it and swap our slots so the site doesn't go down, and application insights where turn it on and we can start getting all the monitoring that Alex loves. The networking here where we can start switching around where traffic goes. So you get a whole bunch, like here's our scale up and scale out stuff. So scale up is vertical, scale out is horizontal. All this great stuff that you can get through here. So it even tells you how much it costs.
Well,
and
a good example of like the platform as a service type stuff we were talking about, where some of this stuff is handled for us, and then some things are there available for us to tweak as needed or as we like.
Exactly. And you can really, there's a lot there for you that you can get down to and go at. So, and I think like diagnose and solve problems is actually pretty cool here, that you can check to see the reason why some things might be up or down. Why is the web app down? Or why is it slow? And it goes through and it kind of leads you through why some things that you can check to see why things might be slow. And obviously we don't have enough information yet to actually show anything. So, but yeah, but it does show, hey, your TCP connection's okay and all that other good stuff. So all built in, and that's neat. So you get your platform as a service information. Cool. So we did that. We did that. Q&A.
All
Oh,
right,
no.
guys. And this is perfect timing. I feel like we're at our last couple minutes here. That was an awesome demo. I learned a lot. I hope everyone else learned a lot. As far as questions, I'm mainly seeing we're looking for some pointers to Azure pipelines. If anyone has something that we can share with Golden Spark in chat.
So like DevOps, Azure DevOps, will we talk about Azure pipelines? How about this, Golden Spark? I will put in some links to the show notes, and that way we can have them in perpetuity. So Katie, I don't know if you still have the link, the let's learn /Azure/.net. Yep, that one. So give me about an hour and then the notes will be updated there.
Perfect. All right, there you go, Golden Spark. All right, Matt, Alex, we covered a lot today. Any closing remarks, anything you'd like to remind the folks who are watching about anything we talked about?
One thing I wanted to mention, I'll just give a shout out to the Azure SDKs. That would be kind of a next step as well if you're a .NET developer and trying to go deeper into the .NET side of things. The SDK is like downloadable packages and stuff that you can include in your project to start easily connecting to different Azure services, like storage and things like that. And it kind of streamlines that platform as a service process where you're just kind of hooking into those services that are readily available. And there's tons of documentation and training around Azure SDK. So that would be kind of a next step if you're looking to go further into the coding side with .NET. Yeah, what about you, Matt?
Yeah, I would. Yeah, definitely check out the Azure SDKs, the links that we put into the show notes, and really, it gets a lot. We covered a lot, and we covered the basics. And really, us developers, we're going to start concentrating on the platform as a service stuff and making the code. I'm glad we had the question about serverless because that's like the functions as a serverless, FAS, and all this as a service stuff kind of gets murky and blurred together. But you're writing code, you're writing it on the cloud, and you're writing it to be resilient and highly available when it comes down to. And when your managers and your bosses ask about it, say, sure, we can cost optimize it, and then whip out that formula and show them how you can calculate the availability for it too. So, but yeah, we covered a lot, and I just want to thank everybody for sticking with us for 2 hours. We did it, Alex. I didn't think we could cover 2 hours worth, but we did it.
We did it. And formulas always impress people. So anytime you can whip out a cloud algorithm like that, it'll be good.
And thank you, Katie, for keeping us afloat. Couldn't do it
Of course, no, and thanks to John backstage for all the awesome GIF work on the fly. That was pretty cool. Great. Well, thanks everyone for tuning in. Thank you both. Check out the show notes. And if you have any questions, you can find us on Twitter or LinkedIn or pretty much anywhere else. But thanks again. That's our show.
Thanks all.
All right. Thanks, everybody.